Hello guys, welcome back to John's Workshop, and in this video, and maybe the one following it, depends how long it takes, we're going to be making or doing the first customer job, if you want to call it that, since I've started the workshop up properly. And I alluded to this in the recent blether video that I did. So this is a ducting swage tool for an ex-work colleague and friend, Andy. So Andy's sent me a drawing through. He's also sent me some stock. So this looks like mild steel plate, flame burnt out to a rectangular shape. So this is what we're going to be using to make the swage tool from. It's largely all going to be milling work. So what I'll do now is we'll go to the screen. I've got Andy's drawing up on the screen and we'll try and show you that on the monitor. It is looks like a scan copy of a drawing, so it might not show up too well, but we'll give it a try on the monitor just to show you what we're going to be making. And then, being it's the first sort of customer job, I need to find myself a clock, at £40 an hour. We probably need to get a clock up on the wall somewhere so that we can just keep track of how much it costs. I'm joking, of course. So I'll bring you back at the screen in a minute. It's £20 an hour, Andy. I'll bring you back at the screen in a minute and we'll have a look at the drawing. Okay, so I hope that's showing up. So this top portion is obviously the piece that you hold in your hand. You obviously thump the top of this with a hammer. This is the business end of the tool, which is quite simple really. It's just got a closely controlled slot milled through it with some tolerances around it. So nothing too extravagant. The thing I'm going to struggle with really probably is these radiuses here. They don't matter. This is just cosmetic, and obviously for your hand, when your hand's sat on around the sort of body of the tool, if you like. So I've not yet decided how we're going to attack those. I don't have any cutters big enough to form that radius, so I'll think about that as I get stuck into it. So first thing I'm going to do is measure the plate up against this drawing, see what sort of stock I've got, and then we'll start thinking about taking the first cuts on the milling machine. So we'll bring you back when we're at that point. Alright guys, we've got the plate in the vise. What I'm going to do first is just block this out a little bit. Now unfortunately the drawing or the dimensions that Andy would have sent to the burners is the finished dimensions, so I don't really have a lot of machining stock on any of these outer dimensions. I thought I'd taught him well, but obviously he's had a bit of a relapse on this one, so never mind Andy, we'll make a good thing out of it, don't you worry. So we'll start, just take a cut across this face. So anybody that heard this mill running on the projects that I've done prior to stripping the head down and changing all the bearings will have probably noticed what a difference that was in terms of there's no squealing, none of those horrible noises that we were getting before. That's just a really nicely behaved milling machine now. Nice and slow. High speed steel 20mm cutter, and that's just clean that up. I've not gone all the way, I've left a bit of a witness, but that's more than enough for me to now sit on that side to clean the opposite edge up. So we'll just deburr that and I'll bring you back when we're doing the other side. I've cleaned the vise out, so I'm just going to drop this in, make sure we're locating on the area that's cleaned up and not the sort of witness area. And we'll just take a light cut over this side. inches a nut. So I'm just going to give that a quick measure. It should be 86 plus or minus 1, and we're 85.58. So that's within limits. So drop that in on a couple of parallels, and I'll put the best side down. They're both similar, to be honest. There we go. So I'm now going to switch the end mill out for a fly cutter, and we're just going to clean this top face up at the same setting. Okay, we've got the fly cutter set up, and I've just stoned the radius. There's a nice radius on the bottom of the fly cutter, so I just stone that. Now this machine is never going to be good with a fly cutter because it's got a geared head, and because they're spur gears like you get in the back of a lathe. Obviously where the gears mesh, there's clearance in the gears, so if you think what's happening with a fly cutter, you've got this, that's the slack in the gears, and every time the cutter comes round it loads up against the gears, and then as it exits the cut at the other side it slackens off, and the motor tries to drive or you know, stops driving quite as hard because it's not in drawing power, and you get this clanking in the head. So this is never going to be a brilliant machine for a fly cutter. It's always going to make a rattling noise in the head. But I'm going to take the lightest skim off these, just off both faces, just to clean the mill scale off. So we'll give it a go and see what happens. Not the quickest process in the world, but that's been fairly well behaved actually. It's at its worst when it's breaking out and you can hear the slack in the gears clacking around, but that's cleaned that mill scale up nicely off that face. So we'll get that out of the ice now, give it all a good deburr, flip it over and do the same thing on the other side. Right guys, I'm on the next sort of setup. Unfortunately I don't have any angle plates of any description, and that's what I could really do with for this operation, is an angle plate that I can clamp this plate to solidly to machine the business end, if you like, the slot that's going to do the swaging in the top of here. So what I've done there is used a series of parallels to basically extend my vice jaws up as far as I can. So these are ground parallels, they're in a terrible state rusty wise, so I've used the best faces against the part and against the vice jaws, and I'm just going to run the clock there now along there. I've just set that up and we'll see how good that is. So we're about 5, this is in thou increments or half thou increments, but each division between the numbers is a thou. So we're sitting there on about 5/10 at that end. We're probably sitting at about 3/10 at that end, so that's within a couple of tenths across its length, which is perfectly adequate for what we're doing here. Okay, we've got our edge finder in the collet chuck. What I'm going to do now is just measure the thickness. The drawing calls for 15mm nominal, it's untoleranced, so I'm going to assume ±1 like we've got elsewhere on the drawing. So we've got 14.65, 14.66. So we'll call that 14.65. Just put that on here. So half of 14.65 is 7.32. Oh, there we go. We got there eventually, finding an end mill. I thought I'd got loads of 6mm end mills, and it appears that most of them are 1/4 inch end mills, and I've just been through my ER32 collet range and I've got everything apart from 6 to 7, so I can't hold a 1/4 inch shank. Anyway, dug around and I found solid carbide end mill 6mm. So we'll run with that. The slot needs to finish at 7mm wide, plus minus 0.2, and it's the depth that's important, so I've got 3mm depth plus nothing minus 0.2. Okay, so I've had a quick measure up of the slot, and I'm 6.06. I've pitched across by the 1/2 mil, so we're going to conventionally cut 1/2 mil down this wall on the back side, and then I'm going to put a clock up on the top of the vise somewhere on the spindle, and then we're going to move back by the right amount on the clock, so I'm not even looking at the dial, I'll just look at the clock to pitch back across, and that will take the backlash out without me thinking about it. So we'll cut this first side. .47, so I need to come this way by just over 1/2 millimetre. So I've moved 20 thou. So, after much upcocking, that should be us unfinished size. .97 with the vernier, 6.96, 6.97, and my size is 7mm plus or minus 0.2. Now the depth, which is the important bit, I've relied on my my quill for that, and I have done some checks on the quill in the past in terms of putting a clock underneath and winding it up and down to see what I get, and it is pretty, you know, it's very repeatable. So this, and I've gone just under the 3mm, so I've got 3mm plus nothing to minus 0.2, and I've got 2.94, so I think that's oh yeah, I'm only measuring this with a vernier. Repeatable, 2.94. Right guys, I've set my bandsaw up for the first time with the horizontal, the vertical bandsaw option. This thing is, yeah, it's not very good. It's a good job I've done it, really. It's given me an opportunity to have a look at it and see its shortcomings, but for what I'm doing here, it will be okay. So basically what I've done is I've marked out the part just with some blue marker, and I've scribed some lines on where the handle's going to be. You know, I've got two options with this. I can either swarf all of that material, or, you know, I can get a little bit out of the job, and save these two bits either side that might come in handy for something else. So I've chosen this option. So we're going to bandsaw. I've marked some radiuses out at the bottom, and I've just, I've used something of roughly the right diameter for the radius that I need to transition. There's nothing really specified on the drawing with that, and it's largely unimportant. So what we're going to do is machine bandsaw one side out, and then I'm going to take it to the milling machine while I've still got the other side intact, and we'll sit on the face that I know is good, and we'll machine this finished side of the handle, if you want to call it that, and then we'll probably pick away somehow at this radius on the milling machine, and then we'll make it good with either a file or a Dremel or something afterwards, and then we'll take it out of the mill, back on the bandsaw, saw the other edge. At that point I've got a decent machined edge then on this first side that's perpendicular to the business end, if you like, down here, that I can sit on while I'm machining the second side. So that's roughly the plan. We'll give this a go, see how we go on. Now I run this bandsaw on the slowest speed in an effort to try and protect the blade life. So this will take a while, so I'll film a bit of it and then I'll do the rest off camera. There we go, that's one side done. We'll give that a clean up and we'll get that loaded up into the milling machine, ready for the next part of just tidying that piece up. Alright guys, we're set up in the vise. On the parallel edge at the bottom we've got a 20mm solid carbide end milling that's got a decent corner radius on it, and I think that's going to be useful when we get into this radius section here to help me pick some of that out. Not quite sure how this is going to go on this machine. It might be a bit much for it, but we'll give it a try. That was fairly drama free. I'm down to my scribe line there. So next job, I'm just going to start picking away into this, and this is the bit that I'm not quite so sure how successful that's going to be, but we'll give it a shot, see how we get on. Alright guys, I've had a bit of a nibble at this. The camera was almost flat, so I've had the camera on charge and just been back in the house for a bit while that charged up. So the way I've marked this out, there's a parallel section of width, if you like, here, and that's kind of how it looks on the drawing. So I've made this radius transition as close to the sort of sketch on the drawing as possible. So I'm just going to measure this, see where we are now. And this should be 20 plus or minus 1. And we're 21.3, so with 1.3 millimeters left to come off there. So I'm just going to zero the axis out. We'll take another 1.3 off there. So that's got an approximated radius on that side now, so there's a little bit of work to do just to tidy up the cusps in there, but there's nothing too much. And again, I'm not quite sure how I'm going to do that. I could file it, I could get the Dremel out, and I've even thought about, now I've got the bulk of the material out of the way, setting this up on the bed like this and using a smaller fly cutter that I've got and try and set it at the right radius and just plunge down through there to clean it out. So we'll see. That might be interesting. We're not in any rush. We're on the clock with this one, so yeah, we could probably chuck another couple of hours into that corner. Yeah, so anyway, enough joking about. There we go, guys. That's manual CNC the second side out. So that's 2 approximated radiuses that we've got in there now. So I just need to think about how we're going to just clean those cusps out of there now, and I'll bring you back when I've decided what that method's going to be and when we're just tidying that last bit up. Alright guys, I've decided we've got enough time into this job already for what it is. These radiuses, if you think fit, form and function, which are the 3 things that you associate with manufacturing, I don't have to worry about fit. They're undimensioned, they're untoleranced, they don't fit to anything, so there's no fit to worry about. From a form perspective, that's the only thing I do need to worry about. The form is all about ergonomics of the tool and how it sits in the hand. And function, they don't provide any function to the tool at all. You could argue they provide some strength if you were using this outside end of the tool, but either way, it doesn't need to be a machined radius to give it that strength. You'll still have the same amount of strength if I do what I'm about to do to this. So the good old Woolies Dremel has been dragged back out of the cupboard, and we're going to set that to use to tidy this area up on the part now. So I'll bring you back and film a bit of that in a moment. Right guys, there we are. That's both sides done. Neatly blended in. Just taking those cusps out. It's taken, I don't know, 5 minutes a side. An hour a side, Andy. 5 minutes a side, something like that, 10 minutes. So for what that is, that's perfectly good enough. You know, it's just to, so you could, you know, when you're holding it in your hand, it's just, if your hand slips down, you're not onto a sharp edge. And talking of sharp edges, that's really all that's left to do on this now. I did ask Andy on this and said, have I got a bit of poetic license with chamfers and break edges? So on the slot itself, because that was so tightly tied up, well, say not that tightly tied up, but on depth, I've gone with a very, very minimal break edge on these corners on the inside of the slot, just literally just to take the burr off. It's almost a sharp corner. Everywhere else, I shall put corners on that I think are going to be right for sort of handling this thing, and largely, you know, these corners here will need sort of a 2-3 mil chamfer, something like that on, so that when it's in your hand, you've not got sharp corners biting into your hand, especially if you're going to hit this with a hammer. If it slips, you know, you've got the risk of hurting your hands there. So we'll put some big chamfers on there, probably across the top as well, because as that gets hit, that's going to mushroom. So if we put some decent sized chamfers on the top as well, that will stop that mushrooming too quickly. And then just around the rest of it, we'll make the chamfers up as we go along, really. So I've not quite worked out whether that's just going to be file work or whether I'm going to stick it in the mill and probably try and chamfer these edges with a tool just to make it a bit more uniform. But I'll bring you back when I'm doing some of that. Alright guys, we've finished all the machining off now on this. So what I did do, I've chamfering these edges. I've chamfered across the back at the same size, so that's all blended in. I also chamfered on the machine a smaller chamfer on these edges. I put 1/4 of a mil chamfer on here, and I put a 0.1 of a mil chamfer across the front edge. So the only edges I've had to blend in are these arcs on the radiuses, and I've just tried to blend them in between the bigger chamfer here and the smaller chamfer there. So it doesn't matter. It's just visual really, so it looks a bit better. So what we're going to do now as a final thought on this is we're just going to give it a quick degrease all over, and we're going to drop it in the chemical black and just black it up, just to give it a bit of corrosion protection more than anything. So we'll crack on now and do a bit of degreasing. So I'll just zoom out a little bit. So basically I'm just using good old methylated spirits for this. I do like meths, not to drink obviously, but it's really good for degreasing, and you don't need a lot of it, you know, just a little bit on a rag. And basically what I do when I'm doing this is I'll go over it once with a rag all over it, because obviously as you're wiping it, any oil or grease residue that you've got that you're wiping off, you know, just goes onto the rag largely, so you're in danger of just spreading it around eventually. So what I'll do is I'll give it a do-over with the rag, and then we'll then give it a second degrease with a clean cloth. Okay, that's at its second full degrease now, so we're happy that that's fully degreased. So hopefully this is going to fit just, certainly widthways just, lengthways just. So that's brilliant. So we'll leave that in. That needs probably 10 or 15 minutes, something like that. So we'll leave that in to black, and I'll bring you back when we're taking that out, rinsing it off, and we'll just give it a light coat of oil then, which forms basically this etches it. It's a corrosion process really. It's an oxidation process, and what that does, it's almost like almost etches the surface. It opens the grain structure of the surface, and then when you give it a wipe of oil afterwards, that gets into that grain structure, that open structure, and that's what gives you your corrosion resistance. And the black colour is just a byproduct of the oxidation. So you know, visually it looks nice, but also you get the corrosion protection as well. So we'll bring you back in a bit when that's done, and we'll have a look at the final thing. Okay, I think that's probably taken on about as much black as it's going to do. Sometimes, depending on the material, it's more successful than others. I think this is mild steel of some grade, I'm not really sure. So it's took a black, but it's not. It'd be good enough once it's got the coat of oil on it. It'll be fine. So what we're going to do now, I'm just going to brush the worst of the sort of the dross off it, because it does, as it oxidizes, it leaves a lot of residue in the liquid. So at some point I need to strain this liquid through a very fine strainer and take the residue out. So what we're going to do now is drop that into here, which is just clean water, and we just give that a rub over. Try not to spill it all over the bench. We'll take that out,
got to get it as dry as you can, as quick as you can now, to get the moisture off it. That's about it. The next job now, very quickly, is oil. And what that will be doing is filling up the open grain structure now. And it also helps with the colour as well. When that oil soaks in, it tends to go more black. What we'll do now is just give it a wipe over, just to take the excess oil off. And there we go. That's the finished thing. That's worth a couple of £100 of anybody's money, I reckon. So I think this is, Andy said this is kind of prototype, I think. He needs to trial this and see how it works, which is probably why we've gone for mild steel. I'm not sure how long this would last on this front end before it all starts getting chewed up, being mild steel. Maybe a future one once Andy's worked out whether this size and everything works for him, is to make something very similar, but either make it out of tool steel, or even make it a mild steel handle with a tool steel insert at the front that's just got the business end on that's going to do the work. You really want this back end to be soft if you're going to be hitting it. So that's probably some thought for a future model if this works. So so there we go. That's the end of the project. Interesting, something a bit different. Nice to be working to somebody else's drawing rather than my own design. So if it doesn't work, I'm not to blame at all. It's to drawing. So that's 100% right first time, Andy, on a first off. So I'm expecting some SPC data back from you. You're going to have to work hard on a batch size of 1, but if only all suppliers were as good as that, eh? We'd have had a much easier life, wouldn't we? So me and Andy used to look after external suppliers in the supply chain, and we're used to the trials and tribulations of looking at suppliers who are struggling to hit specifications regularly and all that kind of thing. So there's a bit of, Andy will understand what I meant with all of that, I'm sure. So rambling on, apologies for that. That's the end of this project. I hope that's been interesting. Certainly interesting for me. I wasn't quite sure how I was going to attack these radiuses. There's many different ways I could have done it potentially, but I think for what it is, to the drawing, they're perfectly good enough. And now it's blacked, they blend in quite nicely, so that worked out quite well. So yeah, interesting project. So thanks for watching, thanks for subscribing. If you're watching the channel and you've not subscribed, please do so and consider putting some comments on, because it's good for me to see what people are thinking about what I'm doing. And we'll catch you all very soon on another video when we'll be doing something else, and I'm not sure what that's going to be. There's various projects in the back of my mind at the minute, one of them being the carriage stop for the lathe. So I've blocked myself some steel out to make that, so that's kind of blocked out rough sizes out of some old steel, so that's potentially a project that we'll be doing shortly. But anyway, we'll catch you very soon on another video, when we'll be making something else. Yeah, bell end. So what we'll do is move it a millimetre, because that'll be a much better distance to move it. Honestly.